It's time to start looking at actually exploiting a SQL injection risk. And what I want to do is use this sample website I've got here to show you how to find this risk. Now this website is from another one of my Pluralsight courses, Hack Yourself First, How to Go on the Cyber Offense. Now this is a really great course for going through a whole range of different risks in web applications. And amongst that set of risks is the risk of SQL injection. So it's a very handy place to go and actually test this risk. Now this site is public. It's over at hackyourselffirst.troyhunt.com. So you can go there right now and test this risk of SQL injection. And we'll be using this site throughout the remainder of the course. So it's a great resource to go and experience this firsthand yourself without having to set up your own database server and web application. Now the idea of this site is that it's intended to represent a way for people to vote for their favourite supercar. So that's why you'll see things like a leaderboard. You can see a supercar here in the banner at the top of the page. And as you can see from the title in the top left corner, it's called Supercar Showdown. You can also register and log in and search and do a few other things that we won't use in this course. But again, if you do want to take a look at that Hack Yourself First course, all of that is used fairly extensively. And it also has a pretty extensive range of vulnerabilities in it. What I want to look at now though, is right down the bottom of the page. So let's scroll down and we'll see that there's a section here on cylinder layouts. And what we can see here is that we have a different number of vehicles for different cylinder configurations. So for example, we've got 3 V8s. Let's go and have a look at those guys. So here are 3 cars, every one with a V8 engine layout. Now what we'll notice in the URL is that V8 appears here in a parameter called cylinders. So this is just a query string. This is all it is. A query string saying, hey, get us the V8s. If we change V8s to V12s, we'll get a different result. It looks just like this. So here are our 4 V12s. Now this is a very common pattern in web applications. The query string parameter is simply describing the nature of the data that the page must show. There's nothing wrong with this. It's a very natural way of building applications. And what inevitably happens is that that query string parameter is somehow impacting the underlying query in the database. So you can imagine having a table somewhere in the database called supercar, and based on the name of this query string parameter, probably a column called cylinders, and then a query is being built up, and it includes a where clause which says, get me everything from the supercar table where the cylinders is equal to V12. So that's pretty basic stuff. Now let's make it a bit interesting. I'm going to change the URL and I want to use just one single character to test for the risk of SQL injection. And that character is this. A single quote. That's all it is. Let's load that page up now. So here we have something a little bit interesting. And clearly this is an exception, an unhandled exception at that. So something has gone wrong in the application. And rather than the application just simply saying, hey, something has gone wrong, and having a nice friendly page, maybe the ability to submit an error report or something like that, instead, we've got this internal exception that has bubbled up into the browser. And the exception tells us a lot of things. So one of the things it tells us here in this section on exception details is that it's a system.data.sql client.sql exception. Now this application is an ASP.NET MVC application, a model view controller application. So a very typical pattern for building web apps on Microsoft Stack today. It's also sitting on top of a SQL Server database. So what we're seeing here is that this internal exception in ASP.NET is returning an exception raised by the database. So that's the bit here on SQL exception. So the database has actually told us that something has gone wrong. And in fact, what it's told us is that there is an unclosed quotation mark after the character string V12. And in fact, what you'll notice here is that V12 is encapsulated by single quotes. Well, kind of. There's one single quote before V12, but two single quotes after V12. Now in the next clip, we'll have a look at exactly why that is. So the other thing that this exception is actually telling us is that this is an error-based SQL injection risk. So I just talked about error-based risks alongside union and blind risks. This is what error-based looks like. It's the database very explicitly telling us something about the internal implementation of the system. And in this case, it's obviously telling us that it can't actually parse the query. We'll look at other really sensitive things that can be disclosed via error-based SQL injection as we progress through the course. But I just wanted to touch on one more thing first. This is an HTTP GET request. So we've made a request to this URL using the GET verb. That's what implicitly happens when you type a URL into the address bar, or when you change one in the address bar, as the case may be here. SQL injection risks are by no means constrained to GET requests. You could have a SQL injection risk in a POST request. So if we filled out a form, for example, we could well see exactly the same response if we had an extraneous quote in there like here, which wasn't properly handled. Many applications these days are also using semantic HTTP verbs, things like HTTP put and HTTP delete, because they have very specific meanings. And the point is that none of those verbs, get, post, put, delete, all of these commonly used HTTP verbs are equally at risk of SQL injection. So even though it's probably easiest just to go into the URL and mess around with query string parameters, this risk is by no means constrained to GET requests. With all this understood, let's now move on and actually start to modify the query structure such that we get this page to do something that it was never designed to do.